Welcome to my channel, and let's look at how to find inverses of higher order matrices using the method of adjoints. Now, we already know how to find the determinant of matrix, and that is very important in this topic. So the following steps are used for us to get the determinant of higher order matrices. No, the inverse of higher order matrices. So the first thing that we do to get the inverse of higher order matrices is to find the inverse of the matrix. So supposing I'm given matrix A, then the first thing I will do is to find the determinant of matrix A. And then I will proceed to find the cofactor matrix of matrix A, and then find adjoint of matrix A. So for higher order matrices, the adjoint of matrix would be the transpose of the cofactor matrix that we obtained in part 2 here. So this part 2 is not this. It's part 2. So the transpose of this matrix in part 2 is the adjoint of that matrix. So once we have this adjoint, and you remember that the inverse of matrix A is 1 over determinant times the adjoint of matrix A. Let me remind you how to find the adjoint of a 2 by 2 matrix. So if I have a 2 by 2 matrix A, B, C, D, if this is a 2 by 2 matrix, so what is the adjoint of this matrix? So the adjoint of this 2 by 2 matrix, I'll abbreviate it as adjoint. So the adjoint of this matrix, supposing this is matrix A, so the adjoint of this matrix A is the matrix that you get when you interchange this D, A, and then interchange the signs. Now, if the sign is positive, then it must be negative this time. This is also positive, so we have negative. So just change the sign. So if the sign was positive, it becomes negative. And if it was negative, it becomes positive. This is the adjoint of this matrix. For a 2 by 2 matrix, that's what we do. Now, so what is now important for us is how do we get the adjoint of a 3 by 3 matrix, a 4 by 4 matrix, and a 5 by 5 matrix, and so on. And that's what I've written here. That the adjoint of matrix A of higher order will be the same as the transpose of the cofactor matrix that we obtained in the transpose. So again, let me just remind you what the transpose is. And the transpose of a matrix is the new matrix that you obtain when you make the rows become columns, or when you make columns become rows. So for example, if this is the matrix A, B, C, D, E, F. So the adjoint of A, the transpose of A, which we denote as A transpose, will be the matrix you obtain when you make the first row be the first column, the second row be the second column, and so on. So this is the transpose of this matrix. Now, so what now remains is for us to learn how to get the cofactor matrix. Once we know how to get the cofactor matrix, we shall get the transpose of that cofactor matrix, and that will give us the adjoint of matrix. And then once we have this adjoint and we have the determinant of the matrix, it's now easier for us to get the inverse of that matrix. So let's look at an example. So this is my example, and the question says, using adjoint method, find inverse if A is this. Using adjoint method, find A inverse if A is this. So the first thing we do is to find the determinant of A. And since A is a 3 by 3 matrix, I chose on the simplest way to find the determinant of A. And so I write, as we looked at the previous, as we did in the previous video of finding the determinant of matrices, I wrote matrix A here, and then took these first two columns and added them here. The first two columns, added them here. So I have these diagonals, 3 diagonals, running from left to right. These 3 diagonals, I multiply along this diagonal and add. You can see this is plus. So I add, this is negative 5 plus, this is negative 6 plus, and this is negative 8. And then minus these entries, minus, this is negative 10, and this is negative 6, and this is negative 4. So when I do this, I get the determinant to be 1. So I now have the determinant. What I want to look for is the cofactor matrix. And then, after getting the cofactor matrix, I'll find its transpose, and that will give me the adjoint. So the cofactor matrix, let's just remember what our matrix was. Let me write what the matrix was. No, the matrix, I can just get it from here. It was 1, 2, negative 4, negative 1, negative 1, 3, negative 1, negative 2, 5. So that is the matrix. Now, so to get the cofactor, I get the cofactor for every element. I get the cofactor for every element. So, for example, this element here, its cofactor will be the determinant of the matrix that remains when I delete the row of that element and the column of that element. So when I delete the row of 1 and the column of 1, the matrix that is left is this: negative 1, 3, negative 2, 5, negative 1, 3, negative 2, 5. And then I come to the second element is 2. I get its cofactor. So I delete the row of 2 and the column of 2. The matrix that is left is negative 1, 3, negative 1, 5. So negative 1, 3, negative 1, 5. So you may be asking, what about this sign? And this sign we already discussed in the determinant when we were looking at the determinants of matrices, and we said that if our matrix, you see this is our matrix, 1, 2, negative 4, negative 1, negative 3, no, this is negative 1, 3, and this is negative 1, negative 2, 5. So we said that the sign for this element will be positive, this will be negative, this 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 will be positive. And they will alternate. And that's why you can see I put a positive here, and I put a negative here. A positive, negative, positive, negative, positive, negative, positive. So they alternate. Okay? So that's how we find those signs. So we were done with this element and this element. So we come to this other element, and we want, and remember, this is not part of the matrix. This is not part of the matrix. So our matrix was this. This was our matrix. This one we just used it to get the determinants. Now, so we want the cofactor for this element, for this position here. And so this position is in row 1, column 3. So when I delete row 1, column 3, I'm left with this. I'm left with this. Negative 1, negative 1, negative 1, negative 2. And that's what you see. It's a plus. Now I come to this element, delete its row, and delete its column. So I'm left with 2, negative 4, negative 2, 5. 2, negative 4, negative 2, 5. And the sign is negative. Remember that the signs are alternating. So now let's come to this other element here, the element in row 2, column 2. And remember that this is not part of the matrix. So our matrix remains to be this. So we are on this element. So we delete the row of that element and then the column of that element. We're left with 1, negative 4, negative 1, 5. 1, negative 4, negative 1, 5. And the sign is positive. And then the next element is this. Delete its row and its column. The matrix that is left is 1, 2, negative 1, negative 2. 1, 2, negative 1, negative 2, and the sign is positive. Remember, the signs were alternating. And so let's now go to the last row. This element, the column, and not the row, and then the column deleted. We are left with the 2, negative 4, negative 1, 3. 2, negative 4, negative 1, 3. Then the next element is this. Delete its column and then its row. We are left with 1, negative 4, negative 1, 3. 1, negative 4, negative 1, 3, and the sign is negative. And then lastly, this element, delete its row and then its column. We have 1, 2, negative 1, negative 1. 1, 2, negative 1, negative 1. So we've now done that. We only need, what remains is now just to find the determinants. So let's just now find the determinants. And so when we do that, this is what we get. This will be negative 5, negative 5, and minus 6. This gives us positive 1. Now what about this? This will be negative 5. There's a minus outside, but inside we have negative 5 minus 3. So this becomes positive. So this is negative 2 times negative, which is positive 2. What about this? This will be 2 minus 1. The sign here is positive, so it's 1. So we do that for all the elements, and this is the cofactor matrix. That becomes the cofactor matrix. So remember, we said once you have this cofactor matrix, you get its transpose. Get its transpose. And so what is the transpose of that? We say we shall make the rows become columns, and or make the columns become the rows. So when we make this first row be the first column, yeah, the transpose is that. So first row be the first column, second row be the second column, and the third row be the third column. So this is the adjoint of our matrix. This is the adjoint. Now, so what is the inverse? The inverse of A is 1 over the determinant times the adjoint. So remember our determinant was 1. So times the adjoint. So we just remember the same adjoint is the inverse. So this is the inverse of matrix A. Let's look at another example to make our working clear. So here is the question. And the question says, use adjoint method to find the inverse of this matrix. Remember, this power means inverse. Power negative 1 means inverse. So again, I've chosen on the method that I said it would be easier for a 3 by 3 matrix to find the determinant. So we find the determinant, we have this matrix, we write it here, and then add the first 2 columns here, and multiply along this diagonal and add, along this diagonal and add, this other diagonal and add. And then subtract the product along this diagonal, subtract the product along this diagonal, and subtract the product along this other diagonal. When that happens, we find our determinant as negative 26. From there, what the next thing is for us to get the cofactor matrix. So what was our matrix? Let's just write what our matrix was. Our matrix was 2, 1, negative 2. Just a minute. I want to create a space to write that matrix. It was 2, 1. Let me just write it on a piece of paper and then I get a place to write. So the matrix that we were given was 2, 1, negative 2, 3, negative 3, negative 1, and then 1, negative 2, 3. So let me just write it somewhere now so that we use it to find the cofactor matrix. Good. Let me now write it. Let me just write the matrix that as we refer to it, it becomes easy. So the matrix is 2, 1, negative 2, and 3, negative 3, negative 1, and then 1, negative 2, 3. This is the matrix. So we want to get the cofactor matrix. We got this, we go for this first element here. And remember the sign will be positive, negative, positive, negative, positive, negative, positive, negative, positive. So that is how the signs will alternate, and that's, we already talked about that. So to get the cofactor in this position, delete first row, delete first column. We are left with this matrix. Negative 3, negative 1, negative 2, 3. Find its determinant. And then the sign, next sign is negative. Now we are in this position. Delete the row and the column. In this position, delete the row and the column. We are left with the 3, 1, negative 1, 3. 3, 1, negative 1, 3. The next sign is positive. We are here. The next sign is positive. Delete this row and that column. This row and that column. So we are left with the 3, negative 3, 1, negative 2. 3, negative 3, 1, negative 2. Then finally, next, this was positive, negative, positive. This will be negative. So in this position, delete this row and delete that column. So level 1, negative 2, negative 2. So we do that for all the other elements. We do that for all the other elements, and then we find the determinant. Find the determinants, and this is the matrix you end up with. This is the cofactor matrix. This is the cofactor matrix. Now, so we find its the adjoint by finding the transpose of this matrix. So this is the matrix we have. So let's find the transpose. Make this first row to be the first column. This second row be the second column. This third row be the third column. So this is the adjoint matrix. So our question was to find the inverse. And the inverse is 1 over determinant times the adjoint. And this is our determinant, negative 26. So 1 over negative 26 times the adjoint. And if you want, you can leave your answer at this point, or you can take these values inside. So when you multiply inside, this becomes positive 11 over 26. This is negative 1 over 26. This is positive 7 over 26, and so on. So this is the inverse of this matrix. And this is how we find the inverse of matrices by use of adjoint. I'll teach you how to find the inverse of higher order matrices using row reduction, or I can say using Gauss-Jordan method. So that's the method I will use today. In the last video we looked at how to get inverse of higher order matrices by using the method of adjoint. So to use this row reduction method, what we must understand is that we'll be carrying out elementary operations. And what this method says is that, supposing I was to write A and then with the inverse, now A with the identity matrix. If I was to write A with the identity matrix, then there will exist elementary row operations that will take A to the identity matrix and then take the identity matrix to the inverse of A. That's what we'll be doing. So we'll be carrying out elementary row operations and ensure that we make this matrix A to become the identity matrix. And those same elementary row operations are performed to the identity matrix and they will carry it to the inverse of A. So let's use an example to make it clear. The question is, use row reduction to find the inverse of A when A is this. So we're using row reduction. So what we do, we write the matrix that we've been asked here, and then there's this vertical line, write the identity matrix. This is a 3 by 3 matrix, and therefore we'll write here the identity matrix, a 3 by 3 identity matrix. So we carry out operations, elementary operations on this to transform it to become the identity matrix. So the elementary row operation that we'll be doing on this matrix, we'll be doing them also on this matrix. So when this one becomes the identity matrix, this will have become the inverse of A. So let's just do that. So I have this element here, this element 1. I want to use it to have zeros elsewhere in the column, so that this 1 is the only non-zero element in column 1. So I want a 0 here, another 0 here. So what you notice is that to get the new row 2, I'll have to take the current row 2, then add row 1 to it. Let's do that. So row 1 remains as it is. So add row 1 to row 2, you have a 0 here. Add row 1 to row 2, this 2 plus negative 1, you have negative 1. This negative 4 times, plus 3, you have another negative. What was this? This gave us 1. When you add this 2, and when you add this 2, you have negative 1. When you add this 2, you have 1 here. And when you add this and that, you have 1. When you add this and that, you have a 0. So we also require 0 in this third row position, third row column 1 position, this third row column 1 position. So to get a 0 here again, you notice that we shall have to add row 1 plus row 3. That's what I wrote. Row 1 plus row 3. So 1 plus negative 1 is 0, 2 plus negative 2 is 0, and then negative 4 plus 5 is 1. 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1. So I have this. Now, so the next thing, I'm done with the first column. So I count the second column, and I have this, in this second row, second column, I have this element. I want this element 1 to be the only non-zero element in column 2. I want it to be the only non-zero element in column 2. So I need this to be 0. This one is already 0. So we are very much fortunate here. This one must be 0. So for us to have this become 0, what are we to do? We're supposed to take row 1 minus 2 row 2. And this should be our new row 2. So row 1 minus 2 row 2. So that means 1 minus 2 times this will remain to be 1. 2 minus 2 times this will be 0. That's the 0 you are seeing there. And then negative 4 minus 2 times negative 1. This will be negative 2. And then we come to this 1 minus 2 times 1. And that should be negative 1. That should be negative 1, you see there. And then 0 minus 2 times 1. That should be negative 2. Then finally 0 minus 2 times that will be 0. So you have this matrix. So you have this matrix, and you can see we've achieved that we have a 1, then zeros below it. Then we have this 1, then zeros above and below. So we now come to this element and use it to create zeros elsewhere, so that it's the only non-zero element in this column. So what are we to do? And I've written here that for us to achieve that, we shall require row 2. The new row 2 will be row 3 plus row 2. What about here? To get a 0 here. To get a 0 here, we require this row 1 plus 2 row 3. This element plus 2 times this gives us a 0 there. So that's what I did. So this row remains what it is. This row remains what it is. We only want to affect row 2 and row 1. So let's begin with the row 2. To get a 0 in this position, we say we are adding row 3 plus row 2. So this 1 plus this negative 1 gives us 0. This 1 plus this 1 gives us 2. This 0 plus this 1 gives us 1. And this 1 plus this 0 gives us 1. So we are done with this row. So you come to this other row. Remember that we are taking, remember that for us to get a 0 in this position, we are taking this element times 2, then add to this. So this times 2, you get 2, plus this, you have the 0. This times 2, you have 2, plus this, you get 1. This times 2, you have 0, plus this, you have negative 2. This times 2, you have 2, plus this, you get 2. So we've achieved what we wanted, because you notice that the first matrix here has become identity matrix. It has become identity matrix. And so we said, once this becomes the identity matrix, whatever shall be here will be the inverse of matrix A. So in other words, the inverse of matrix A is this matrix 1, negative 2, 2, 2, 1, 1, 1, 0, 1. This is the inverse. The method that will be used is row reduction or Gauss-Jordan. So let's look at another example, just one, to make it clear. And this is the example. Use Gauss-Jordan method to find this inverse. So again, we're just doing the same thing we've been doing. We have this matrix, and then beside it, we write the identity matrix. Do elementary operations on the entire matrix. When this becomes identity, whatever will be here will be the inverse. So remember that for us to make this an identity matrix, we require this element to be 1. So that's the first thing I do. I make it 1. There are various ways of making it 1. We may want to subtract this row 3 from row 1, and this will be 1, will become 1. Or just simply do what I did. I divided row 1 by 2. I divided row 1 by 2. So when you divide row 1 by 2, this one becomes 1, a half, negative 1, a half, 0, 0. So this is the matrix we then get. We use this one that we created to have zeros elsewhere in column 1. So you need a 0 here and a 0 here. So how do we achieve a 0 in row 2? I've said that to get a 0 in row 2, you'll take row 2 minus 3 row 1. And to get a 0 in this position, we'll take row 3 minus row 1. So let's just do these operations. So this element times 3 subtracted from this, it was 0. This element times 3 gives you 3 out of 2. Subtracted from negative 3, this gives me negative 9 over 2. Because the LCM here will be 2. And this will be negative 6, then negative 3. So it's negative 9 over 2. It's okay. So we are done with this. Now this element here times 3, you get negative 3. And then subtracted from negative 1. Subtracted from negative 1. So this becomes positive. And that's why you have 2 here. Do that for the entire row, and you have this. You get this. Do it for the entire row, because I've also multiplied this by 3 to get 3 over 2, and then subtracted from 0. So I have negative 3 over 2. So I'm doing it the entire row. Now come to row 3. We've said we shall take row 3 minus row 1. So 1 minus 1 gives us 0. Negative 2 minus a half gives us negative 5 over 2. And then 3 minus 1 gives us 4. So you do it for the entire row, and you have this. Now, so the next is to create a 1 in this position. So how do you create a 1 in this position? By multiplying row 2 by negative 2 over 9. So multiply row 2 by negative 2 over 9. So you multiply the entire row by that. And that will give you 1 that position. Because we want this 1, and then use it to create zeros in these other positions. So let's see what happened. Yes, so that's what I did. I just multiplied row 2 by negative 2 over 9. So when that happens, this by negative 2 over 9 gives me positive 1. This by negative 2 over 9 gives me negative 4 over 9. And this one by negative 2 over 9 gives me a third. And the other one will give me negative 2 over 9. And the other one will give me 0. Now, once I have this one, I use it to create 0 in the other positions in column 2. So I want a 0 above it and a 0 below it. I want a 0 above So I come here. How do I get a 0 here? So for me to get a 0 here, I require that I take row 1 minus a half of row 2. That's what I wrote. And for me to get a 0 here, I require that I take row 3 plus 5 out of 2 of row 2. And that's what I wrote here. So let's do those operations and see what they yield. So row 2 remains where it is, because it's the one we're using to create zeros in this position and this other position. So row 2 remains where it is. So a half of this subtracted from this a half gives me 0. A half of this subtracted from this -1 gives me -7/9. A half of 1/3 subtracted from a half gives me a third. And then a half of this subtracted from 0 gives me 1/9. A half of 0 subtracted from 0 gives me 0. We want a 0 here. They said we'll take 5/2 of base plus this. So 5/2 of 1 plus 5 plus base gives me 0. 5/2 of base plus base gives me 1. You can just work out that one, because this is 4 plus 5/2 of -4/9. And you'll see that 2 go here -2 times. So what we have will be 4 minus 10/9. And that the LCM is 9. And this will be 36 minus 10, which gives you 26 out of 9. Which one was that? It was, where are we? Yes, that 26/9 here. 26/9. So I think I was pointing at the same, at a different value. It's this 26/9. 26/9. So 5/2, we are done with this. 5/2 of this, then plus this, it gives us that. So you do it for the entire row, and this is what you get. This matrix. Get that matrix. Now, so the next thing, we have a 1 here, we have a 1 in this position, we require a 1 in this position. So how do we get a 1 in this position? By multiplying row 3 by 9/26. So row 3 by 9/26, the entire row 3 by 9/26. This will be 1. This will give us 3/26. This will give us -5/26. And this will give us 9/26. Now that we have this one, we want to use it to create a 0 in this position and another 0 in this position. So how do we get those zeros? And that's what I wrote in my next step. My next step, I said that to get a 0, in this position, I'll take row 2, the element in row 2, plus 4/9 of element in row 3. So the element 2 plus 4/9 of element in row 3. I do it for the entire row. And then for me to get a 0 in this position, I'll take the element in row 1 plus 7/9 of the element in row 3. And I do it for the entire row. And that's what I wrote here. So when you do that, you achieve this matrix. That's a matrix to achieve. Now you can see that we have achieved the identity matrix in this position, so that whatever is here is the inverse that we wanted to get. So that is the inverse. And that's what we have. So that's how we use Gauss-Jordan or row reduction method to find the inverse of matrices.